All right, welcome to The Explainer. Today we're going to dive into something pretty wild, the hidden world behind just a single tap on your phone.
I mean, have you ever really stopped to think about what happens when you ask your phone to do something smart? You tap an icon, you ask Siri a question, and boom, it just works. It feels like magic, right? But it's not. It's actually this incredible chain of events, this command that stretches all the way from your screen to some of the most powerful computers in the world. So, to really wrap our heads around this, let's follow the journey of just one single command. Something super simple, like creating a new note. You know, it feels instant, but we're about to trace the amazing path that request really takes. Think of it like peeling an onion. We're going to start at the very surface, the button you actually see, and then peel back layer after layer, digging all the way down to the deep, deep engine room that you don't. Okay, so our journey starts right where you'd expect, with the part you actually interact with. That clean, simple button, it's not just a pretty picture. It's really the very, very tip of this massive technological iceberg.
And what's really interesting is that even this tiny button is governed by a really clear philosophy. Apple tells its developers, hey, when you make one of these shortcuts, it needs to do something essential. It has to be actionable. The whole goal is for it to be predictable, so predictable that it just becomes second nature. You know, muscle memory.
And here's where we peel back that first layer. What you see is a simple, clean icon for a new note. But for developer, well, they see a block of code. They use a language called Swift to create something called an app intent. And that's basically just a little message to the phone's operating system that says, hey, my app knows how to do this specific thing. Okay, so how does a developer actually hook up their app to all that smarts built into your phone? Let's go one layer deeper and look at the tools they use.
Well, it turns out developers are swimming in this huge ecosystem of tools. All of them are designed to plug AI into, well, pretty much everything. You've got AI plugins for your office software, you've got browser extensions that translate on the fly, chat apps with bots, even code editors that help you write code. The goal is always the same: weave that intelligence into the apps we already use.
And for our new note example, Apple gives developers these specific building blocks. We already talked about app intents, right? That's the verb, what the app can do. But then you have entities. Those are the nouns, the things the app understands, like a note or a folder. Queries are how the phone finds those things. And then there's this cool part called Siri flexible matching, which is basically machine learning that lets the system understand that make a note and create a new note mean the exact same thing. It gets how you talk. But wait a second, what's actually powering all these cool developer tools? What is the real intelligence here that's understanding what you want? That brings us to the next layer down, the brains of the whole operation. The core tech here is something called a large language model, or an LLM for short. And honestly, the best way to think about it is with this analogy. Imagine a super librarian in this unbelievably massive library. This person has read every single book, every article, everything. So when you ask them a question, they don't just point you to one book. No, they instantly pull together ideas from everywhere and give you this perfectly clear, combined explanation. That's kind of what an LLM does.
And this super librarian is, wow, incredibly versatile. It's not a one-trick pony. It can translate languages, summarize a huge article for you, help a programmer write code, even create a brand new image just from you describing it. This is the raw power, the raw potential that developers are tapping into.
And here's a really key point. Developers don't just use the AI like it's one single thing. They pick the right tool for the job. So, for a really complex problem that needs some serious thinking time, they might reach for a heavy-duty model. But for a quick task, like our new note example, they'll use a much faster, more efficient model that gives you that near-instant response you expect. So, where does this giant brain actually live? I can tell you, it's not on your phone, no way. To run these massive models, you need a mind-boggling amount of raw computing power. And that brings us to this whole specialized world called high-performance computing, or HPC. We're talking supercomputers, massive data centers, and we've finally arrived at the deepest layer of our onion, the engine room. In this engine room, it's not just a bunch of servers blinking in a dark room. It's a whole ecosystem built by absolutely brilliant engineers who live and breathe this stuff. People like Jiari Feng. He's one of the architects behind the kind of infrastructure that makes all of this possible, a major contributor to the open source tools that thousands of developers rely on every day.
I mean, just look at this timeline. This is a career spent at the absolute summit of computing. We are talking about building deep learning systems from scratch on the world's #1 supercomputer, then designing another one for the #5 fastest, and then taking all that knowledge and building the AI infrastructure for products like WeChat that have 1 billion users.
That is the level of engineering we're talking about here. That's what it takes to power the AI in your pocket. And if you want to put that skill into perspective, just look at this number, 97%. While working on that Sunway Taihu Lite supercomputer, he was literally handwriting code in one of the most fundamental programming languages to squeeze out 97% of the machine's absolute maximum theoretical performance. That is it's an almost unbelievable level of efficiency. It's like getting every single last drop of power out of the engine.
And there you have it. That's the whole journey. From a person handwriting code on a supercomputer to achieve near-perfect efficiency, all the way back up through all those layers to that simple, elegant little shortcut on your phone.
So you gotta ask, why? Why go to all this trouble? What's the real payoff for connecting our little phones to these gigantic digital brains? Well, the vision, the big idea, it's about so much more than just making things a little easier.
As the CEO of Google DeepMind, Demis Hassabis puts it, the real goal here isn't to replace people. It's to become an extension of our own capabilities. All that technology, from the supercomputer to your screen, it's all designed to boost our creativity, to help us solve bigger problems, and to augment our own intelligence.
So, the next time you tap a button or ask your phone to do something, maybe you'll remember this incredible journey, from a simple design idea, through the developer's toolkit, into the mind of a giant AI model, and all the way down into an engine room powered by supercomputers. All of that immense power, it's right there, activated by your touch, waiting for you. So the only question left is, what are you going to ask it to do next?